Thank you for downloading this podcast from The Reedy Clubby Show on Talk Radio 702 and 567 Cape Talk. For more, please go to 702.co.za or capetalk.co.za. Talk Radio 702 and 567 Cape Talk. The Naked Scientist.
All right, we are moving on then. Thank you very much for tuning in. You can start calling us now, actually. Any questions that you have for The Naked Scientist on 021 446 0567, 011 883 0702. And of course, The Naked Scientist is brought to you by Grolsch Premium Lager. Grolsch, choose interesting, not for sale to persons under the age of 18. Chris, good morning.
Morning.
Lovely to chat to you. Let's talk about beef, Thomas's favorite subject.
Well, do you know, it's interesting because when Nawazi got in touch and said, can we have something we could chat about at the start of the programme? And I was thinking, 702, I always associate with you and Thomas. Well, and I thought Thomas and I associate with food. And then I was thinking beef. And there's this story in the journal PNAS this week, which shows that, in fact, Thomas, you might be in for a bad bit of news because, for the benefit of the planet, we may have to take beef off the menu in order to make feeding the 7 billion plus of us here on Earth sustainable in future. There's a paper by Ron Milo, who's a researcher at Israel's Weizmann Institute of Science. They have taken data from American agriculture because there's very good data for the amount of food that Americans consume, the amount of fertilizers, the amount of animals, the amount of land use and so on. They have put all that data together, and what it shows is, or they've been able to compute from that data, how much you have to invest in terms of land use and fertilizer and all that kind of thing per calorie you get out of any given foodstuff. And beef uses 28 times more land, 11 times more water. It emits 5 times the amount of greenhouse gases and 6 times the amount of fertilizer is consumed in producing each calorie of beef compared to other foodstuffs like pork, poultry, other dairy and eggs. And even if we grow plants, if we grow food crops that are plants, then they produce between 2 and 6 times less of the bad stuff and consume 2 to 6 times less of the bad stuff compared with beef. So most people judge beef to be not that much of an impact on the environment, but these figures paint a very different picture. It's extremely bad for the environment to grow beef as a foodstuff, and we might want to consider in the future educating people. The point that Ron Milo and his colleagues make in their paper is, if you ask the average man in the street, they'll say that probably beef is no better or worse than any other meat. These figures tell us a very different story.
Very, very interesting. And I wonder how the agricultural community then will have to respond. This is not just about the health of the planet, it's the economy as well. And there's no point us making money and improving our economies if our planet is suffering, because ultimately we will lose. Anyway, our lines are open for you. Let's go to Caroline. Oh, you're calling us from Gaborone in Botswana. Good morning.
Hi, Reedy. Thanks for taking my call. I'd like to ask the Naked Scientist. I often have this discussion with my husband. When the air conditioner is working, you know, you have the 2 buttons in your car where you can either get air from outside or you can recycle the air that is inside the car. On which setting would the air conditioner be most effective?
Hello, Caroline. Definitely
Hi.
with the air being recycled. Because if you're bringing in air from outside, assuming that the outside air temperature is much higher, and that's why you're trying to air condition the car, then the air conditioner has got to do a lot more work in order to take the energy out of the hot air you're bringing in and return cold air to you in the car, compared with if you were to feed it cooler, damper air from inside the car, which it would then remove the water from, your breath effectively, and cool it down a bit more. So therefore the best way to do it is to keep the air recirculating. The aircon units have got filters on them, which will soak up some of the excess moisture, dust particles, dandruff and that kind of thing, small numbers of bugs, and return cleaner, colder air for you. So that's the best way to do it, because the aircon unit can only take the temperature down by a certain amount in any cycle of air going through it. And if you feed it air at a very high temperature and it drops the temperature by, say, 10 degrees or so, that will obviously still be a lot higher than if you feed it air which is much cooler and it drops it by 10 degrees or so.
Silo. Ooh.
Hi, Reedy.
Okay, your line is very, very bad. Silo, are you still with us?
Yes, I'm still here.
Okay, let's go through it quickly. Yeah.
I just want to know from Chris, the International Space Station. Is it just stationary, like the communication satellites, or is it also rotating?
So the International Space Station orbiting the Earth, is it stationary or in motion? Chris?
Yeah, what he's referring to is whether it's in a geostationary orbit or not. A geostationary orbit is a special distance away from the Earth, which means that any object placed there is turning and orbiting the Earth at the same speed that the surface of the planet is turning, and that means that relative to the Earth's surface, an object placed there will remain static or stationary. We use that position of orbit for communications satellites because you want to always be able to see your satellite so you can send it a signal and have it bounce it somewhere else. That part of space, though, is 36,000 kilometres out, and that's a long, 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 long way from where the International Space Station is. The International Space Station is at a much lower altitude, and it is not in a geostationary orbit. So if you're on the International Space Station, you're seeing the sun rise and fall, sunset coming every 40 minutes, 20 minutes, 40 minutes, something like that, because you're going around the Earth many, many times every hour. As a result, no, you're not geostationary. They're not spinning the International Space Station either. The Arthur C. Clarke model of a space station is one that turns at just the right rate to spin so that if you were in one of the arms of the space station, you would experience a sort of artificial gravity because you would be experiencing centripetal force, so you're gluing yourself to the wall of the space station. This is not the case with the International Space Station. It's on a flat trajectory in space, just going around a bit faster than the Earth is.
Let's go to Peter in Krugersdorp. Good morning to you, Peter. Welcome to the show.
Good morning. Chris, I travel a lot, and whenever I'm in the northern hemisphere and I look up at the sky and look at a jet plane, whether it's in Europe or United States, wherever, they always seem to have a vapor trail or a condensation trail behind them, all of the planes. But nowhere in the southern hemisphere, and I've been to Santiago, I've been to Australia, I've been to Karachi, and all over Johannesburg, you almost never see this condensation or vapor trail occurring. So what is the difference in the atmospheric conditions that means in United States and Europe you get vapor trails, and nowhere in the southern hemisphere you get this at all?
An interesting observation. I've not made that myself. The reason you see a vapour trail at all is because the jet engines that are powering the flight are burning a hydrocarbon. It's a kind of kerosene, which is a bit like paraffin. And when you burn a hydrocarbon, which is a mixture of carbon and hydrogen atoms glued into long chains, then the products of that reaction are carbon dioxide, which is an invisible gas, but also water, H2O. And when the water issues from the engine, admittedly when it comes out of the engine, it's at something like 1,000 degrees C. But very quickly, at those very rarefied conditions up there high in the altitude, at maybe 10 kilometres up where these planes are flying, the temperature is under 100 degrees, or minus 100 or so, minus 70, minus 100. And so the water very quickly freezes, and you form ice crystals in the sky. And the vapour trail you're seeing are effectively very high clouds formed artificially from the exhausts of the aeroplanes. This should happen regardless of where you are over the Earth's surface. Why you wouldn't see them, or see them for so long, in the southern hemisphere, I'm not clear why that should be. They will definitely form, and planes fly there at the same height. I wonder, though, whether it's just down to the density of flights, because the northern hemisphere is home to more than 3/4 of the world's population, and the vast majority of the flight routes that happen are over the northern hemisphere. And because the southern hemisphere is more sparsely populated and you see fewer air movements, you may therefore see fewer trails just because they're less easy to see. And so the ones that are there, if they're less frequent and they're getting blown away quite quickly, you're not actually going to see them that often. And I wonder if that's the explanation. But the physics and chemistry of it is it should happen regardless of which hemisphere you're in, because it's basically the frozen exhaust of the aeroplane.
Fariza in Auckland Park, hi.
Hi, how are you, Reed?
Good. Your question?
Yeah, I just want to ask Reed, how healthy it is to drink water first thing in the morning with empty stomach?
Drinking water on an empty stomach?
Yeah, first thing in the morning.
Okay, Chris?
What specifically do you want to know about that?
I think he wants to know if it has any impact at all. How healthy is it to be drinking water first thing in the morning on an empty stomach? Shouldn't be a problem, should it?
No, not at all. We have we've evolved to take in water as the main source of the fluid in our body, which is water, and the stomach is extremely good at absorbing it. And it shouldn't really matter whether it's the night time or the daytime. If you drink water, it's absolutely fine. You don't have to put food in your stomach first. It might make a difference in terms of how full you feel, because if you drink a big glass of water, it does stretch your stomach a little bit, and if you're trying to lose weight, then some of the signals that come from the stomach regulate appetite, and so some people do put extra volumes of fluid in so that they feel fuller than they would otherwise do before they eat, so they tend to eat less. So that might be one modest difference, but it shouldn't make a health difference at all.
All right. Let's go to, is it Jerry in Pretoria? Hi.
Yeah, hello, Rudy, you well?
Yes, I'm well.
I just want to ask Chris, was that data from Israel, was that done with feedlotting or was it natural grazing?
What they've done is to take the entire country, and so they've got the Department of the Interior and also Department of Energy data for all of the agriculture across the country, and so that includes the very arid west as well as the much more fertile and better rained on, less arid grasslands which are used elsewhere. And actually, I think one of the referees of the paper probably picked them up on this issue that you're sort of raising, because there is a comment in the discussion on the paper saying how you should also consider the irrigation of the plant growing areas and food crops which could be used for animals and so on. But yes, it takes into account the entire country.
Are you satisfied? Are you happy?
Thanks, bye.
Thank you very much. Thank you. Let's go to Daryl in Cresta. Hi.
Hello, good morning. My question is very simple. Why do people have different blood groups?
Okay, well, what is a blood group, first and foremost? The answer to that is, were you to look at a red blood cell, which is the tiny little thing, it's about 1 micron or 1,000th of a millimetre tall by about 5 or 6 microns, 5,000ths of a millimetre long, and if you look at it from the side, it's shaped a bit like a number 8 because it's thin in the middle and fat round the edge. Those cells, and there are billions of them in your bloodstream, have on their surfaces markers. And these markers are proteins which come in 3 different flavours. There's no markers, there's A markers, and there's B markers, and in some people there's A and B markers. Those markers present themselves to the immune system, and the immune system recognises them, and it's expecting to see the marker corresponding to you, and if you don't have that marker on your cells, then it regards those cells as foreign. And it's a consequence of human evolution that we have multiple sets of these markers, because when humans first emerged from Africa, there was huge genetic diversity in Africa, and as people migrated around the earth, then slowly populations were isolated for a period of time, and some of these blood groups became more common or less common in some of those populations. And so we've ended up with different patterns or marker combinations in different parts of the world, to a certain extent, and that means that you've got these different blood groups, and it's down to genetic diversity. And part of the reason they probably exist is that some of them are also associated with being resistant to certain diseases, and so you can see that in evolutionary terms, people would have evolved to have a certain blood group or set of markers on their cells. This, by chance, would have given them a resistance or an ability to overcome a certain environmental threat or a disease, so that blood group or that set of markers would have become more common in that small population, and slowly as the population diversified, you got a certain number of these things, and we now have the 3 markers we have, A, B and AB, and O being the one with no markers. Other animals have many more. I think sheep have something like 5 or 6, maybe even 7. So other animals have them too.
Thank you very much. And let's go to Roger in Muizenberg. Hi.
Hi, Rudy. Question for Chris. Seems to be talking a lot about temperatures and water today. When you're cooking, they often say you must bring the water to the boil. What I want to know is, does the fact that it's boiling actually do anything in itself, or is it just the temperature you're looking for? In other words, if you bring it to 99 degrees instead of 100 degrees, will it cook just as quickly, or is it something to do with the boiling that you're looking for?
Hi, Roger. Very interesting question. I've never really thought about that, but it's an important point because when the water is just warm, there will be convection currents in the water, which is where if you've got hot water at the bottom of the pan where you're heating the pan, water that is hotter is slightly less dense than water which is cooler, and therefore the hotter, less dense water will rise and displace the cooler, more dense water at the top down towards the bottom. So there will be a natural circulation. But when the water is physically boiling, you're producing bubbles of gas. You're giving enough energy to the water to actually break apart the associations between the water molecules so they can expand to form big bubbles of gas. And so the boiling, those big bubbles coming from the bottom to the surface, will intensify the mixing action. And also they will introduce agitation and a sort of gentle bombarding of the food with the water. So I think probably actually the physical act of the boiling probably helps to mix round the water and any other things dissolved in the water and flavours and spices and that kind of thing, and also helps to move the food around. And therefore you're probably going to get a better cooking than if you just had a constant exposure in one position under those circumstances to your food item that you're trying to cook. So I think it probably does make a contribution. It's not always a good one, though, because sometimes it might bash the food to pieces and make your vegetables go soggy. So under certain circumstances, continuous heat at a certain temperature is good. Under other circumstances, boiling, I think, does help.
Thank you very much, Roger. And Chris, you also have a question about water in food, eggs in particular, right? Chris in Randburg, hello?
Oh, right. Oh, hi.
Oh, sorry.
Am I on the air, really?
Yes, you are.
Okay. Chris and Reedy, good morning. Chris, I've got one of these little round egg boilers in which you can boil up to 7 eggs at a time. And it's you put in water and it seems to boil it by steam. But now, what puzzles me is that you have to put in much more water for 1 egg than you do for 7 eggs, which to me is counterintuitive. And I'm trying to figure out how this thing works. You know the little machine I mean?
I've heard of it, and we've been asked this, I think, once before, and I think it's just down to volume. I think it's down to the fact that if you put 7 eggs in the thing, then they take up space, and they're therefore not going to have water, because the eggs, if you were to put the same amount of water in as if you were to put 1 egg in, then the water would take up a lot more the water would take up space, the eggs would take up space, and the thing would overflow, and then it would boil over. Whereas if you've got less water in there for just your 1 egg, if you've got only 1 egg, then you haven't got 6 other eggs displacing the water out of the way, and therefore it's not going to overflow. So that's probably why you need a bit more.
Very interesting question. Thank you, Chris. Thank you. And Steph in Randfontein, hi.
Hi, Rudy. Hi, Chris. How come if you have a couple of drinks you have a headache, and specifically with red wine, and certain people don't get a headache?
Yeah, I think it's probably because there's certain people who don't get a headache buy the good stuff. That's my view. They buy the South African good stuff. Certainly true. You can buy wines which are more headache-inducing than others. And it comes down to chemicals called congeners. And when you produce wine, the action, or what's happening, the action of fermentation, is that yeasts, which are tiny microorganisms growing on the surface of the fruit, usually grapes, they will use their biochemical know-how to convert sugars and some other things in the grape juice into alcohol, and they will also act on some of the other things which are in there, so they can convert other chemicals in the fruit. And different yeasts make slightly different contributions biochemically, and that's why different wines have slightly different flavours. And also the chemical composition of the fruit juice in the first place that you start with will make a subtle difference to the flavour and texture of the wine. Now, some wines will therefore be higher in some of these things that can give you a headache than others, just naturally. Also, they sometimes add things to wines during the production process which are not terribly good, and they can result in it becoming more headache-inducing. And I actually have a friend in Australia who runs a diagnostic and also an analytical chemistry lab, and he is a very big wine fan, and he decided, since he's got millions of dollars worth of some of the best analytical equipment in the world, he would feed in some examples of some very, very good red wine and some very, very poor red wine, and see if he could spot a biochemical difference between the two, so that he could have a headache test. So he would be able to say to people, the headache likelihood or a headache scale of a wine. I don't think he's cracked it quite yet, but he did spot 1 or 2 molecules which are more likely to give you a headache were you to drink a lot of that particular beverage.
Forewarned. Thank you very much, Chris. We'll chat to you next week.
It's a pleasure. Thanks, Reedy. Bye, everyone.
Thank you very, very much. And I'm sorry, I must say my SMS screen froze for a second and I wasn't getting SMSs. I will print them and we'll save them and I'll ask them next week. Sorry about that. The Naked Scientist was brought to you by Grolsch Premium Lager. Grolsch, choose interesting. Not for sale to persons under the age of 18.